Okay, recording in progress. Raphael, you behave yourself. Hey, Visa. All right. So we're doing club news. This evening, we've got Michael Overstreet doing a presentation. A lot of you may know Michael. Michael, say something.
Yeah, hello everybody.
Here's Michael Overstreet. Michael Overstreet, you probably know from RoboGames and Maker Faire. He's the humanoid guy. So he's actually really a person, but yeah, he's, I don't know, I kind of think of him as a humanoid. Maybe he's one of those clone robotics people. Not nearly as creepy though.
Well, his hydraulics look pretty good, but his facial expressions are obviously fake.
Michael, you're muted. Maybe that's on purpose.
No, I'm just hanging out, chilling.
RoboGames, good times, huh? And Maker Faire.
Yeah, unfortunately, it looks like RoboGames is dead. So,
well, that's happened before, hasn't it?
Yeah, but
it's like the clone robotics. It comes back.
Yeah, I mean, I hope it comes back, but it doesn't look good.
It comes back and kicks and twitches.
Yeah.
Well, you know what? The good times were had. We were there for them, right?
Yeah, it was an awesome event. It's sad that robotics is becoming more and more popular, and we don't have a venue or event to compete in. I mean, I think the closest one would be Japan if you want to do humanoid robots. Well, I mean, of course, you got BattleBots in Las Vegas if you can get into that.
Yeah, if you can't lose enough money fast enough. All right, what else? What other club news do we have this evening?
Yeah, they don't.
Hey, Stephen. Okay, let's see what's next.
I think you just gave me a good idea there, Cam.
What's that?
How about BattleBots, but with sort of replaceable shielding and body parts and stuff like that. So basically, an inexpensive version, same kind of idea, but without all the cost.
Did that?
Well, I figured out with BattleBots is getting robots to interact with each other is difficult. The easiest thing to do if you're going to have a contest where robots interact with each other is just have them try to smash the hell out of each other. But even then, and I don't mean to dismiss it. The BattleBots is radio control, so there is that. But anyways, we won't have that argument here.
Because normally the argument for how to make it cheaper is just smaller. So
yeah, that's a good point.
The majority of the cost of hosting RoboGames was the combat arena for the most part, wasn't it? The insurance because of all the combat robots, right?
Yes, it was.
But the combots was the
Is
draw
what drew all
too.
the crowd. Like, yeah.
Yeah, but my point is, if we had a Nerf version of that, most of that would go away.
There's actually, I mean, okay, well, Nerf version like of the big ones. Sure, I mean, one of the competitions that I really enjoyed watching at RoboGames the last years was, I think the group that was hosting it is from Arizona, but they were doing like biped mech warrior combat, and it's all airsoft guns.
Yeah,
so like they don't actually break each other, but they don't.
Yeah, paintballs.
Yeah, sure. Larger size paintball.
Yeah.
That was actually pretty cool with the first-person views and all the things they had going on with that.
It was really cool. And then they basically, the event organizer provides the target pads to handle the scoring. So yeah, they mount basically the destructible combat targets like all over the robot, and then that's what scores the system. And then the only thing explicitly defined is a radio link to be like, you are destroyed, shut down. You are destroyed.
Well, it was some kind of miniature city street, wasn't it?
Yeah, it was.
It was like a town. Yeah.
Yeah, a little cityscape. It was you basically you get bonus points for actually being a humanoid versus you're allowed to be either a quadruped or a humanoid, and I think you get like some kind of multiplier for only having 2 legs. And then you just see the ones that are quite, they just walk up and push over the human. Just shoot them while they're down. It's like, oh well.
All right. Any more club news? Let's move into what I need help with. Is there anything specific somebody needs some help with?
I'm
We've got
looking for ideas. I'm looking for something that has to be really, really cheap and be able to trace a human inside a room, but it has to be really cheap and not internet connected.
Not what?
It was really cheap.
So it doesn't have to be super high tech, but it has to be really cheap because it's gonna be for disabled people to call trays to come to them. Because most disabled people, they cannot carry tray. So I'm making a moving tray, a tray that moves around the house, so people can put stuff on and then move them wherever they want.
So it has to be able to navigate within a house and then find the user it's going to bring a tray to.
Yes, but has to be the cost is critical.
Is it actually a tray? I'm not clear on it.
Yeah, it's gonna be a tray
Okay.
in wheels. So imagine how someone that he has to use crunches or a walking stick. He cannot carry it around.
Okay. Well, you're talking about a smart table.
Something like this, but it has to be really simple, really cheap. That's what I'm saying. This is very critical.
Okay. What is cheap?
Cheap is the electronics have to cost less than £30, $30. Let's say
$30.
The overall robot. Are you looking at 500 or 250?
that's what I'm saying. That's what I'm saying. Technology has to be really low tech to keep the cost down because these people they don't really care to have.
Now, I don't think that's limited to disabled. I think that's a general thing, a tray table that can reliably get from one place to another. So, you know what I'm saying? And if anything, if anything, the economies of scale would decrease the price of it once something like this became commonplace.
That might be in the future. At the moment, I had some people and they want it for nursing homes or people that they are in the house and want to be semi-independent.
So here's the thing. Are you talking about building let's see, you come to the Ross discussion group, right?
Yeah, that's what I'm saying.
We can talk about it there. We can talk about it.
Okay,
There's a lot of good
fine.
There's a lot of good discussion groups going on. The voice in intelligence group and the Ross group, and then we have the Builders SIG that's on penultimate Wednesdays. So you guys, check in on those things, and a lot of good problems being solved actually. Any other problems? Any other I need help with? Jim, good to see you. Going once, going twice. Jeremy, all right. Let's move on to what are we moving on to? We're moving on to show and tell. What do we got for show and tell this evening? I see something at Maker Nexus. Yeah. don't you tell us about the HackerBot there, Young?
This is data. Front.
Yeah, so it's a hacker bot with everything on it. So head, Raspberry Pi here, and the elephant cobalt arm with a custom gripper made by Hackerbot Industries. So yeah, I just put together the gripper yesterday, and so right now I only tried the send the command through serial, which they have, but there's like no middleware yet, like ROS and others. So it's pretty much bare bone, but the components seem to be working. Yeah, except for like few UX like problems like powering off and so forth. But yeah, it's pretty interesting in a way that it moves, it has LiDAR, it has mapping, it can dock.
So does that have the AI hat?
It does not. I
Is
I
it,
did
is it
not.
Raspberry 5 in there?
Yeah, it's Raspberry Pi inside.
Is it
Yeah.
Raspberry Pi 5?
5.
Okay. And you're running Raspbian?
Uh, the default one, I guess. So
Yeah,
yeah.
probably Raspbian.
Mhm. And like I also suggest Ian that like it would be good to try Jetson like Orin Super. Then because then like the now ROS is also like taking advantage of CUDA and so forth. So probably a lot of like recent new GPU accelerated ROS packages can be easily used.
So you've got that's got a shelf on it, doesn't it? Put the
Excuse me?
camera where the LiDAR so we can see the LiDAR.
Uh,
Yeah, make it okay. So yeah, you've got a shelf on there up a bit. Yeah. So the LiDAR, you could put things on that shelf and it doesn't impede the LiDAR. You know, iRobot, it seems, has stopped selling the Create 3. Okay, and BotVac's getting long in the tooth, although you can still get those through eBay for like 150 bucks refurbished. But this guy, you know, with that little shelf on it, is nice because it doesn't block the LiDAR. Yeah, really excited about Rossifying this thing. And those eyes are very cute.
That is still vacuum.
Uh, yes. So my
Yes.
son tried to put this, right? You see this like the feet, and like I said hell no, because then like it will get dirty. So, but technically, like the vacuum base, like the HackerBot guys did not touch, like because anything you like modify, like what is existing vacuum, that's cost, right? So like so that is like working vacuum, so like you get the cheapest one there with a lot of sensors and like all the software already, and then like they
Having worked at Nito for 13 years, I can tell you it's actually a damn good robot vacuum cleaner. Just saying.
yeah. So they I thought like if you don't vacuum, the battery can last for 10 hours ish. Yes. Because like when vacuuming like with all the motors on, it can vacuum for an hour or two. So without like that heavy duty work, then like it will like last much longer. So actually like that is like very good base to begin with, and then if you put like nice things on top, like Raspberry Pi or like Jetson, and then the arms, then yeah, that's like a pretty good mobile base.
Green, blue.
So like Like I personally like don't know what to do with this head, but there are other people who are excited by the head and then the eyes, and it can speak, it has camera here. So like that head is like pretty sophisticated one. And then like people who are interested in like human robot interaction find it also like very good platform to
From what I
like, play
understand,
with.
it's a very high quality speaker.
Yeah, so like HackerBot guys really did like excellent job of putting the hardware together. But
Yeah.
then like software wise, yeah, there's like many things to do, I guess.
Well, what I've observed is that there are Arduino and AI guys, a lot of AI going on there, which is interesting because I think there should be or some kind of crossover, between ROS and AI.
Yeah, that's where like Jetson, like Orin Nano can like add like many interesting thing as well, and it can also fit in like this space too. Like the form factor is like almost same as Raspberry Pi, so yeah, like,
Very good.
that's.
Okay, it's a chat bot. Thank you very much, Young.
Thank you.
Who else has a show and tell this evening? Who else has a show and tell this evening? Oh, we got Dee Dee. All right. Hang on a second here. Let me spotlight you.
So I'm teaching a class at no, I'm just doing a talk library. So I came up with, I think I mentioned last time, I'm experimenting with mechanical design. So this one's a cam drive over here. It's driving a bottom lip here. And here's just a geared design. Oh, I just dropped. So that's it. But it's fun doing the little experimental designs because it's a Raspberry Pico with a small form factor and a simple servo. So then it's a small price that you can give for students. So yeah.
Thank you very much. Dee Dee. Let's see, I've got something here. Let me get this cranked up. This is sharing my screen. I need to enable screen sharing. All right, this is Smarty 2, part of the Smarty game, based on the Create 3 DL06 LiDAR, Logitech C270 camera, and a homebrewed ultrasonic sensor. Thanks to Mike Wimble and Ralph Ganock. So here I've got the robot located in the hallway. I shall attempt the Floorbot Challenge Phase 1. I'm going to do it with waypoints here. So let me set some waypoints. Phase 1 of the Floorbot Challenge is to go from one end of the room to the other and back. Phase 2 is to identify an object in the room. And phase 3 is to fetch the object. I think we've had 2 or 3 people do phase 3. Patrick Goebbels, among others. So let me I'm going to put these breadcrumbs here. And with any luck, the robot shall navigate from one end of the room to the other. So exciting. Yeah, so this is some stuff that we do at the Ross discussion group. If you're interested in Ross, expert or beginner, join in. And this is the standard framework for robotics. There is no learning curve. It's a learning cliff. Yeah, so this is this is the Ross visualizer here. The robot's navigating around. This is a MockBot URDF Unified Robot Description format that we've created. Some of us are working on a book called MockBot. We're building the TurtleBot, Mock TurtleBot, 28 different ways. Got like 3 different bases and 3 different LiDARs and 3 different cameras. And so we're trying to beat Mike Wimble in publishing our book. So that's our goal.
So you're saying it's as easy as falling off a cliff, huh?
Yeah, it's that easy. It's just that easy. So here he comes. He's on his way back now. It's kind of exciting. This is navigating. Oh, the thing here is this is actually running off my phone network. So I have my phone set up as a hotspot and I'm doing this. That way I'm able to do, remote demos. Let's see what's going on. We'll look at the navigation stack. Okay, he's into some recovery behaviors here. Let's see if he makes it. Running weight. I'm gonna help him out. I'm gonna set the pose, reset the pose. Oh, that didn't work out well at all. I'll rescue him with some teleop keyboard here. This is robot babysitting. Oh, bear with me. I'm going to go back here. Gotta love live demos. And let me reset that endpoint. So that wasn't a complete phase 1, but let's at least let him get home. Yeah, so I've got this one running off of the phone network, and I've got my bot vac running off of the Wi-Fi. And I'll be cobbling together the Roomba using Sergey's code and Ross Lunin documentation. So there he goes. He's at his home now. So that's it. Any more demos out there? Show and tell. Any more show and tell?
Or
Going once, going twice.
It's Jeremy here. You got a couple of minutes. I can share something about a servo motor.
Go for it, Jeremy.
You might be interested in. All right. So first of all, I am going to.
Hey, Jeremy, I don't think you have your video on.
No, you're right. I don't. I got to start my video. And. About, can you guys hear me?
We can hear you.
Hey.
Yeah, so for an order that I'm doing here, I'm using something that's an STS 3215. It's a servo motor, but what's really cool about this little servo motor, first of all, it's they're metal gears, which helps greatly. Also, they come in 2 specs as far as voltage. This one is a higher voltage. It's a 12 volt, and let me just dump it out here so I can show you. Comes with some pretty nice aluminum servo wheels, and most servos have like a range of motion. And for those of you who are familiar with this, sorry if I'm boring you, but for those that don't, it's actually pretty cool. So most servo motors, as you know, have a range of motion, like let's say, I don't know, 135 degrees or 270 or whatever. And this is a little bit different. It's a little bit unique. On the box, I really should take one of these apart for you guys. But anyway, on the box, it kind of shows it. And what makes this unique is, first of all, it's daisy chainable. So you've got connectors on here where you can connect the signal in. So you've got your power and then your signal. So 3 wires, and you can daisy chain it and keep on going. You can do 253 of these.
I'm sorry, Jeremy. Are these Dynamixels? Are these Dynamixel servos?
These are, if you want to get the brand name, they're VTech, but they are
VTech.
made by a
Okay,
couple
I know
of
those
companies.
guys. Yeah.
Yeah. So
I hate to interrupt, but those are actually ripoffs of Robotics servos.
yeah, there's a lot of stuff in China that's a ripoff of a ripoff of a ripoff. So I'm not vouching for necessarily the company. I'm just for the kind of servo it is. So these will actually rotate, as some of you probably already know, completely 360 degrees. It can also give feedback as far as voltage drop and position.
Or are you giving it like serial commands?
Yeah, and there's actually a little magnet inside and a magnometer for feedback of position. So that was the one thing that I thought was really cool, is that for the price point, what did these cost us? I think they cost us about $15 US.
Yeah, you probably have to buy 50 at a time, don't you?
How did you guess?
I know those guys.
So we bought about what was it, about 40 of them.
I've got some of their kits,
Have you?
and what I liked is they've got a little electronic speed control that's for servos that does the PWM thing. It's like $10. It's really cheap.
Yeah. So, and the best part is the fact that you can daisy chain them, so you can you don't have a whole stack of wires coming in at the bottom. But anyway, no, I just thought I'd mention that if you haven't seen them. Yeah,
I need to
they're pretty
replace some of
versatile.
my Darwin servos.
Anyway, that's
Very
all I
cool.
got for you
Thank you,
guys.
Jeremy. What else for show and tell? Anything else this evening? Oh, Bill Spangler's here. How about that? Going once, going twice, Dr. Ed, Ralph Hips. All right, let's go to the presentation time. Is that what we do next? Let me double check my notes. So many times I've done this, you'd think I'd know. Actually, I do know. After show and tell, it is the presentation. So without any further ado, Michael Overstreet, take it away.
Okay, hello everybody. Can I share my screen?
Yes.
Trying to right now. Can everybody see my the screen now? Yes, no?
It's black, and for me, it's not refreshed
Not
yet.
yet.
Okay.
A long way to Missouri.
There we go.
You are in Missouri, aren't you?
You see it now?
You are in
Yeah.
Missouri.
Yes,
aren't
I'm
you?
in.
Yes.
Missouri.
Missouri.
Okay, so hopefully everybody can see my screen. You can hear me. Hopefully the internet connection is really good. So I'm going to do kind of a presentation on humanoid robots. It's a really in-depth. We could talk for hours about humanoid robots. I mean, we could talk about hours for just all the stuff I've seen for the past 3 or 4 days. So for everybody who may or may not know me, I'm Michael Overstreet. You can call me Mike. So right now I'm a robotics facilitator, ignition lab at Operation Breakthrough in Kansas City, Missouri. I teach STEM education. I also do the first robotics Lego first tech challenge and first an FRC for after school kids, so on. So my big claim to fame is that I participated in RoboGames. I started in I think it was 2005. I missed the first year, unfortunately. And just because I've been to so many RoboGames, I have won 1 or 2 medals per year. I've collected a nice little trophy case of medals, but I normally just compete with the humanoid robots, and like I said, now I'm a STEM educator. So some of these are AI generated slides, and I was just kind of having fun experimenting with different things. But if you want the slides, I can share the slides.
Very fine.
Okay. So one of the cool things that RoboGames did for me was that I was able to meet lots of people throughout the world who were really interested in robotics, especially humanoid robots. So one of the cool advantages is that RoboGames provided me is I could visit friends throughout the world and check on seeing what they're doing in the field of robotics and so on. So RoboGames, like I said, that got me started back in 2004, 2005. Mainly humanoids. Most people, I think, in this group have been to or know a lot about RoboGames, so we don't have to really go into too much detail about RoboGames. Now, most people, when they think about RoboGames, they think about this. They think about BattleBots. BattleBots is what everybody showed up to see. So, just a quick side note. In a lot of ways, it is kind of a failure on my part because I'm a huge advocate for humanoid robots, and I was never able to get human robots to be big, especially in the U.S. If you go to places like Japan, especially South Korea, and even some places in China, you got a big called Robo One, and it's huge and very popular events. And unfortunately, that never really happened at RoboGames. I think pretty much throughout since 2005, it's been me and maybe 1 or 2 other people in the U.S. So, and with humanoid robots getting so big now, it's unfortunate that we don't have an event in the U.S. to participate in. So I'm sure
there was humanoid soccer too.
Yes, there's all kinds of cool things we did with humanoid robots, humanoid soccer, kung fu. We had a lot of autonomous events. Basketball, soccer, kick a soccer ball, shoot a basketball, dash, you name it. We had lots of really cool humanoid events, both autonomous and RC. Of course, kung fu. Everybody loved kung fu, especially with the big 5 kilogram and higher robots, weight classes. But like I said, it's partially a failing on my part because I was heavily involved in humanoid robots at RoboGames, and we just never could get that exposure. Of course, everybody knows what a robot is. Robot is basically anything. Your cell phone is a robot. So humanoid robots, it's kind of both those very strict as far as 2 legs and 2 arms. People say 2 legs, 2 arms, just looks just like us. But you can tell nowadays there's all kinds of variations on the human form, very similar, but they're just slight variations. And of course, everybody seems to be trying to develop a humanoid robot right now. So I think the big point of my conversation or talk tonight will be is that as we've been getting, it's been humanoid robots becoming more and more maybe popular, or everybody seems to be wanting to develop one. I remember my first RoboGames in 2005, and I think I had multiple conversations with people at RoboGames about the basic argument is function more important than form, or is form more important than function? It seems to be that the debate, so especially about 2005, everybody was telling me it's the function, it's what the robot does. You design the robot based on what function or what activity, what job that you want it to do. Now it seems to kind of that popular opinion seems to have flipped. And when I have a conversation with somebody, they automatically assume that the best robot would be a robot that looks like us.
Well,
And because you need the robot to work and perform jobs and tasks in the same environment that we live in. And instead of changing our environment, you make the robot just like us. When I was a little kid, I saw, I don't know if everybody's seen Forbidden Planet, but one of the cool things about Forbidden Planet is that they did show the aliens, the Krell, I think is what they were called, but they said, I think the professor made a point of saying, well, look at the door frames, look at the apparatus, the equipment, and then you can visualize kind of in your head what the aliens looked like. But so that was kind of stuck in my brain. And when I have these conversations with people, I think, what is the most important thing? And I still think that we've gone too far, I think, to the humanoid side now. Everybody's thinking we have to have a humanoid robot. We have to look exactly like us. And I don't know, as an engineer, as a person with an engineering background, it's hard for me just to be 100% humanoid, even though I'm a huge fan and a huge advocate for humanoid robots. I think there still should be some thinking about what is the best design for a situation, because a humanoid robot can be a huge overkill, but we can get into the advantages or disadvantages of having a humanoid robot. But like I said, a humanoid robot can be a huge overkill in expense and complexity for a task. And so I showed this picture is because there's variations on the humanoid form, what kind of hands the robot could have, what kind of feet. Some people are actually thinking, putting the robot like on the picture on the right on wheels, and then they have 2 arms and so on. A lot of people think that a biped, which I've experienced, is a biped can be very difficult to get it to walk, balance, and I mean, I love Legos, and I have a lot of kids that I teach who love Legos. And I just think, how would a humanoid robot, a bipedal robot, walking around on a floor full of Legos, how well is it going to walk? And you really don't want a humanoid robot to fall on somebody. So these are just like kind of design considerations I think people need to think about. You might think, well, you're supposed to be promoting humanoid robots, but yes, but I think we still have to be smart, and we need to look at the applications, and we need to look at what function the robot's going to provide. We need to be efficient and cost effective. Is what I'm trying to get at. I bring this picture up. Everybody should know who this robot is. But I've always thought, I should patent this, but I always thought, why limit a humanoid robot to two arms and 2 hands? I've actually seen some Japanese and Chinese inventors give you have a arm attachment to your body, so you have a 3rd arm or a 4th arm or so on. So to me, you shouldn't just think of it. You shouldn't limit a humanoid robot. I mean, some people would tell me that I'm talking blasphemy or whatever, but I don't think you should eliminate a humanoid robot just to 2 arms and 2 hands. There can be some added functionality and added one humanoid robot could do more than just a job of one human being if it had multiple arms and hands. Just it's another design consideration. So, the big thing, so when Asimo, the Honda robot, came out, it's been years now. I think it's finally been retired about 4 or 5 years ago. The hardware was the big stumbling block for years and years and years. Is how can we get a robot to balance and walk on 2 legs and be smooth, be natural, and so on. And so whenever you talk about a humanoid robot, I always like to tell people that actuators are extremely important. So, and what I mean by that is that actuators are going to make or break your robot. And with a humanoid robot, you need high torque, but you also need some speed. You need that balance. And usually that means you're going to have a very expensive, very complicated, very complex actuator. Or you call them servos, actuators, whatever you want to call them. I've heard it called different things. But you also, and then of course with a humanoid robot, it does help to have sensors, gyros, accelerometers, force feedback, like for your hands. You don't want a humanoid robot to pick something up and crush it because it's applying too much force with its hands. So just more design considerations that I think everybody needs to think about. So this is what I mean by actuators, servos. This is friends of mine, Robotics, very similar to the servos that we were showing off a little bit before during the show and tell. Now with the hardware, I still don't think we're quite there yet. With the hardware, one of the most important pieces of the hardware, I mean, walking is important. Having the legs is important. But one of the most important pieces of hardware is the hands. Because if the humanoid robot can't pick anything up, can't have some little bit of dexterity, I mean, you can. I'm sure everybody's seen the news about humanoid robots in factories and so on. They've got to be able to do something that is a viable job, and since they're in a humanoid environment, they need to pick up tools or pick up objects or press buttons or press levers or do all those kinds of stuff. You're going to have a very effective hand. And I know there's been a lot of work and development in the last 20, 30 years on that. I think we're getting very close to having very dexterous, very agile hands. But I still think there's going to be still a lot of work yet to do on that. We'll see how and how that comes in the future. So I'm not really going to, single out one robot or one robot companies because there's so many. Of course, everybody knows Tesla, and Tesla's developing and working on their Optimus robot. So they got a 3rd generation hand. As you can see in here, I'm not 100% sure this is the 3rd generation, but it's very close as to being their 3rd generation. And if you look at the fingers themselves, they have force feedback sensors in there. The interesting thing is that one of the cool things about being a STEM teacher is I get to talk to high school students, and sometimes they come up with some of the most interesting ideas that if you're not thinking outside of the box that you wouldn't think about as an engineer. But I've had a few my high school students ask me, do you really need 4 fingers? I mean, yes, you probably need a opposable thumb. If you're trying to pick something up, you probably need a opposable thumb, but do you really need 4 fingers? Can you get by with 3 fingers or 2 fingers? And the reason why I mention that is because adding fingers is adding cost and complexity to a robot hand. So like I said, I'm just trying to get people to think like I've been thinking for the past 20 years about what humanoid robots should look like, or what's the most effective, cost effective robot or design. I have to. Some people probably don't know me as well, but I have to add 3D printing. I think 3D printing in the building of a robot, it's been a great tool for me. I remember, I don't know how many people remember back in the early days of DIY 3D printing when the MakerBot Cupcake kind of came out. I remember going down to my hackerspace in the Kansas City area and seeing a cupcake for the first time. And I think I spent months trying to print out robot parts with that thing. And of course, since then, I regularly use a 3D printer to print out brackets and parts for my robots. I just like to add that in because I also wrote a Make Magazine article, and I think another article for Robot Magazine about printing out 3D parts for my robots. And we're talking about, the early days of RoboGames, probably 2005 to 2010, when I was going like maker fairs and so on. So I always like to mention 3D printing because I'm also kind of known for that. Also known for that too. Now, batteries. So actuators, I think, are going to be a huge issue for a lot of companies trying to develop a humanoid robot. But I think the next and probably not most important, but one of the, 1A, 1B kind of thing is batteries. So there's a lot of people on social media. You can tell they're not engineers. You can tell they're business people. They're accountants. They're futurists, influencers, futurist people, always talking about, human robots, they can work 24 hours a day, nonstop. One robot can replace 3 workers because you're going to have 3 shifts, and I just laugh. I mean, I don't know if there's the battery technology is that sophisticated right now to have a 24-hour humanoid robot battery. I mean, you'd have to have a gigantic battery. One of the funny stories that some of my students like me to tell is I keep when you watch the Terminator movies, you got Arnold Schwarzenegger running around, beating people up, fighting constantly. I just keep thinking in my brain, keeping in my mind is if that was today, the Terminator robot batteries would be drained in like 2 or 3 hours. So if you if you're Kyle Reese, all you have to do is just run faster than the Terminator for about 3 or 4 hours, and
Runs the batteries.
and keep and just keep the Terminator from charging his batteries, and then the movie's all over. So my high school kids get a kick out of that story when we talk about batteries and limitations of batteries and so on, and how battery technology. I just don't know if battery technology is quite where some of these influencers and business people think it is, because most of the humanoid robots I've seen have like Camp may be able to talk about his humanoid robot, but I'm thinking about what, 3 or 4 hours maybe on a charge.
2 hours. It's supposed to run 2 hours. Yeah.
So, if you have to constantly, yeah.
At what activity level though? That just being on, or is it actually moving, picking itself up off the ground, carrying weight?
We'll find out. We'll find out.
Yeah. So when these business people, when these business people are, influencers are talking about, Tesla robots are going to be able to work 8 hours or more, 16 hours, 20 hours a day, and I'm like, I need to see that before I believe that.
Okay, I'm looking at the battery life. It says about 2 hours.
2 hours.
But, to your point, is that 2 hours of sitting in a wheelchair or running around?
Doing parkour. Yeah, right.
And a lot of people saying that they want the humanoid robots in the factories and they want them to pick up heavy objects and carry them from one station to the next. So the battery's not going to last that long. So the other thing I keep hearing online, people talk, oh, whoops. How do I go backwards?
You'd have to have a charger at your workstation. So they walk to one workstation, plug themselves in, do a couple tasks, and then unplug and go to another workstation.
You could have the charger in the floor wirelessly.
Yeah.
Yes. But that's all things that I think people need to think about. It's not just a humanoid robot that hopefully my screen come back. It's not just a humanoid robot.
Oh, God.
The robots just put their hands up and get wirelessly charged up.
Well, because it was like if we're talking about you need to put wireless charging pads in the floor, right? I mean, you've just broken they're working in the same environment as you are, principle, right? Is now you've modified the work environment to support the robot.
Although it might not be a bad modification.
Might not be a bad modification, no. But it was like, but if you're gonna modify it, I mean, do you need, as Mike said, it was, you've decided to modify. Okay, so is the humanoid still the best answer if you're gonna modify it?
Yeah, so the thing on batteries is right now, so in terms of lithium, right now our lithium ions like 250 kilowatt hours. Oh. Right. Hello. Right now, our lithium ions topping out like 250 watt hours per kilogram ish, maybe a little less, maybe a little more. But there's a new technology, which is silicon anode lithium, which should take us up to 500 watt hours per kilogram. And the company behind that is already shipping it for military drones now. So they're going to move it to, also the Cattle, I believe. CATL, the battery manufacturer, is going to ship it as well. So Ampuris has it here and Cattle has it in China. And those will be out. So that'll basically double the battery. The gotcha with lithium silicon anode batteries is lower cycle life. So you only get like a couple thousand, you only get like 1,500 cycles out of it. So it's not going to be a car battery for a while because it's too short cycle life.
Oh yeah, this is great information. Yeah.
What's the recyclability on those? Because existing batteries are still basically not.
We can just ask the humanoids to recycle batteries.
Oh.
We don't have to do it anymore.
Sorry, the sun got it.
Well, eventually they'll just return to the earth. It just take a very long time.
Yeah.
Well, companies keep coming up with newer technology. Supposedly, the lithium ion are like almost fully recyclables in prototype stage. So
It's just what cost effectiveness is still the barrier, right? It's like, sure you could, but is it economical?
I just saw something in the last week that says that they've improved that a lot.
Okay.
Yeah, cool. This is great information. Yeah, I'm not a battery expert. One of the things that when you're a humanoid robot builder, programmer, and just somebody who plays with humanoid robots, there's so many areas that you have to explore and think about. Sometimes you're kind of spread a little thin, kind of a jack of all trades, but not a master of any one thing. So this is good information. This is just a picture of some of the battery technology they're using for EVs. I'm not really sure how applicable these will be to humanoid robots. It's going to be interesting to see what happens. Okay, so this I keep accidentally hitting twice. So AI. So we can't talk about humanoid robots without talking about AI now. Everybody is trying to use AI to make humanoid robots more effective, be able to do more things. All I can say is that I'm trying to get us up to speed on AI and how AI can be used in robotics. there's so much happening. It's so happening so quickly. The one couple things I've learned though is that with a large language model based AI, and I've experienced this just using them, is that they can hallucinate, and basically they're very creative. Sometimes they are too creative. They're like a somebody trying to write a kind of a historical biography, and they add fictional characters in the background to add flavor and to add more readability and more entertainment, like a TV, a historical TV movie that adds a figures in the background to add something for the main character to talk to, but they're really not based on any person. Large language models have that tendency to be super creative and invent things that don't exist. So for the longest time, my kids at school were having fun seeing all the creative things that not 4 fingers, but 5 fingers or 3 fingers, or all the kind of little goofy things that large language models will do.
I think it's 6 figures, isn't it?
Yeah. So so AI brings a lot of promise, because you can. I don't know if you've seen the videos where they take a robot dog and they have AI running on the dog, and it teaches itself how to walk, so it's flopping around for a longest time, and then eventually it learns how to walk. There's a lot of cool things that AI can do, but from what everybody I've been talking to has said to me is that with like large language models, you have to train it on or large language model based AI. You have to train it on everything you want it to do, and every step. What they're trying to do is trying to figure out a way to be like us. And as far as we know how to walk, we know how to pick things up, we know how to interact with our environment. So if you if you give a robot, especially like a humanoid robot, those skills, then when you tell it to go pick up that object and you tell it what that object is, then it already knows how to walk over to the table or wherever it is, and it already knows how to pick something up. And then it can pick it up, and then it can take it to where it needs to go. But so instead of training a robot, on millions of different things, activities it needs to do, they're trying to figure out how to train it so it can do individual tasks, and then build all those tasks together for a job. If that makes sense, I may not explain that very well. I'm not exactly an AI expert.
So it has a group of basic functions that it can apply to whatever situation you put it in.
Yeah.
Right. Exactly. Now, but I've also heard that they're having some issues with large language models. So if you ask a large language model, I need to go, I want to go to, let's say I want to go to Japan for a maker fair. How do I get there? Sometimes large language models have a hard time breaking all the steps down you need.
Yes. Yeah. This is a common reproduced result from LLMs can't plan genre of papers. They don't do well on repetitive tasks because it's essentially talking to itself over and over again, and that really increases the chance of a hallucination goes up. You have like a 10% chance of a hallucination each step, and then you have 20 steps, or you have 10 steps. Now you have like a 70% chance of hallucination. So the LLMs can't plan, can LRMs paper that was published has a nice graph that shows how performance of one of the newer models like O1 scales with the complexity of the problem. For robotics, what people have been looking for is more video language action models. So right now, the like one of the state-of-the-art ones that just got open sourced is the physical intelligence model, which is now open, so you can just download it. There's also a new paper called Scaling Laws for Robot Data for Imitation Learning or something of that nature. All those papers show you what the scaling laws are. The big gotcha from me, and I've worked with these models for like a long time. I was on frontier research at this stuff, is that there's an irreducible error term in the scaling law. And that's like 90%. You know, you get top out around like 99%, maybe 99.9% if you're really lucky. And that's just not going to fly for most robots.
Yeah, it's I'm always oh, sorry. Yeah, I'm always curious what ultimately, if you have self-driving cars and if they're based on an LLM AI, that you're going to eventually going to have the car basically hallucinating, and the same
Yes.
thing with the humanoid robot. So I've always been curious about how they're going to get around that problem.
Yeah, the way that they're getting around it right now is hitting a wall. So, or not being able to get around it. Literally in the case of the self-driving cars. Like if you take an AI, like a full end-to-end learning self-driving car, and you take the person out and you have all the data in the world, you know, maybe 100 miles the most before it cracks into the wall, maybe less. Just run a Tesla in FSD mode. I would love to do this as like an experiment. Take it to a test track and just have it run around in a circle until it crashes and see how many miles you actually get off the thing.
Yeah,
Anyway.
it's interesting. It's interesting to see all the different companies trying to incorporate AI into robotics now. If you're a robotics company, if you're looking for funding, if you just put AI in your name, I think somebody is going to be interested in funding your company. So if whatever you're doing robotics, just make sure you put AI in the company name, and I think that would help you out with getting funding.
We were talking about this in the group that does for like AI vision and navigation and stuff we do on a whatever Thursday night. And what kind of database would you have to put into a machine and have a local intelligence in the machine to have the capabilities to, let's say, navigate inside a room and go grab an object by looking at it and recognizing the object? I mean, how many terabytes of data do we have to have, or how many processors do we got to have to do all that quickly?
Well, the physical intelligence,
yeah,
the physical intelligence model is like a couple of gigs at most, so it would fit. At Willow Garage, we had the whole thing running on what's now an Intel NUC, and we were able to navigate successfully and pick objects. So.
Yeah, that's what I was thinking, because you can get, I mean, we don't have a limit on memory really anymore. Terabyte sticks are nothing. You know, you can just buy those. But then you get into how long does it take the computer to go through this information and find what it needs? And what would we have to use for processors to do that? Do we use a couple cell phones? I mean, what level of technology do we have to have for good functionality locally? Now, without going out on the cloud, because that takes a lot of time. That's what we were looking at in navigation is, well, you got to, ask it to go to the refrigerator. Well, it can find it, but first it has to go out on the cloud and figure out where the refrigerator or what it is.
Well, for ROS navigation, we can do that all on device, and that's scaled right now. So ROS nav is just all on device, and the refrigerator, your house is a database. You can have high resolution maps all on device.
I see. Okay.
What's more of a problem is novel objects. I mean, theoretically, we at Willow Garage, this was been, 10, 15 years ago, we were downloading the entire IKEA catalog and putting it into the robot. So you could just grasp all IKEA objects. We bought one of everything in IKEA and scanned them all with laser scanners so we could create a data set.
Tony, is this object recognition within ROS?
Yeah, I don't know what happened to the code, but back in Willow Garage, we had a ton of stuff on 3D object recognition. by using like marching cubes fits from models
Okay,
to
all right.
recognize objects in point cloud and laser
Oh.
data.
So if you had a 3D scan of an object, you could match it with a point cloud. It's
Exactly.
not the fuzzy like match.
Yeah, but
It's
it's super reliable.
I've definitely seen exactly that shape.
Yes, I mean, if you want to recognize IKEA catalog item cups, that's perfect, right?
Yeah.
But not what you want if you just want a cup.
Yeah. It can't tell you that is generally a cup, but it will tell you that it
So,
absolutely is.
Tony, I'm still curious about the relationship to Ross. Is that it's seeing the object? Do you associate that with a location or something?
Yeah, so that I just don't want to take over this presentation for this, but the detector model is, I feel bad because I'm like taking over this presentation, but the
That's okay.
detector model just ran against a point cloud and output an XYZ in the point cloud. So at that point, you need like your high level planner to decide when to engage the detector and all that and which things to detect and whatnot, or some system. And for a lot of the experiments we were doing, we just kind of scripted it and said like, scan the building until you find the cup, and the robot would like wander around until it found a cup and then grab it.
Mhm.
Hopefully
Okay,
it would
cool.
be a clean one.
I'll look into it and continue the
Yeah.
discussion on the mailing list.
Yeah.
Thank you.
Yeah, okay.
Yeah, no problem. I think I need to do more research on Ross and how to use AI with Ross. That's something
We have a Ross discussion group every
Yeah.
Tuesday evening.
Yeah, I probably have to tune into that group, get some ideas. So with this slide, I really don't want to get into who I think the best humanoid robot company is, because I'm not a business person, and you know, I don't really care about giving out investment advice to people. So there's so many different companies. I mean, there's just numerous. I've lost track of how many humanoid robot companies that there are right now. It's just unbelievable.
Isn't that awesome?
Yeah, I mean, I think it's awesome. I just, we could probably spend a couple hours trying to figure out all the different companies. I also hear this all the time. The influencers, the people on YouTube talking about the TAM. It's a business term. It's the total addressable market, and I only put it in here. I really don't care about this, but I do want to put this in here and just talk about is that everybody in the last year or so has been talking about the huge market for humanoid robots, and I think Musk has even said that he thinks that there going to be at least one humanoid robot per person in the world. And some people have said that eventually there could be 2 or 3 or more humanoid robots for every one person in the world. So
I wonder what the car to people ratio is.
Yeah.
Who's going to fix all of these things?
You are, Stephen.
No, I retired. I'm done.
Yeah.
I mean, there's plenty of people in this world that don't even have electricity, but that's another thing.
Yeah. But I just think it's interesting because I always keep hearing people say, oh, yeah, there's going to be 2 or 3 humanoid robots per person. So, there's going to be billions, and companies are going to be astronomical. And
In the United States, there are 811 cars per 1,000 people.
Wow.
Okay.
In case you're interested.
How many of them run?
Almost 1-to-1.
So, yeah, I mean, there's a possibility that in 10, 15, 20 years from now, there could be one humanoid robot per person in the world. I mean, I would love to have a humanoid robot butler myself.
I'll give you a thumbs up on that.
Kind of done some of that, yeah.
And so this is another slide that I just put in for informational purposes. I heard so many arguments online about how much humanoid robots are going to cost. I know Musk has thrown around the $20,000 cost, and I just don't to me, that's unbelievable. It's like, I don't know, as an engineer, I don't know how many meetings I've been in where I'm sitting in a meeting and you have the business people and the vice presidents talking to a client, and all of a sudden they're throwing out these really low ball cost to do things, and you're just like staring at each other. The engineers are staring at each other, going, "How are we ever going to do this?" At that cost. And it's the same with the humanoid robots. If you think of all the complexity, all the actuators, in a humanoid robot, I normally
This is where the reality distortion field comes in, Michael.
yes, exactly.
I think I'm joking.
Yeah, and then you throw in the complexity of an AI. It's all AI driven. So with the humanoid robot, you've got the complexity of the hardware, you got the battery, you got the actuators, and then you're going to add onto that an AI. It's AI driven, and it's all AI software. And I'm going the maintenance, and then I think about the
There you
maintenance,
go. Yeah.
and actuators. I would love an actuator just to last forever. But if you have like 30 actuators in a humanoid robot, one of them's going to give out. You may get a year or two, but you're going to start having a failure here or there. It just the way of the world. So
Yeah, I was reading about them, and some of the really cool ones would have, like harmonic drives, which are a special gear set, and they're very accurate, but they break. They can't take stress like a heavy hit or something that they can break the gears. It's like, how are you gonna keep all this stuff reliable in a machine that's got to operate in a factory 24 hours a day, 7 days? Oh my God.
Yeah.
I mean, it's hard enough to get a forklift to run like that, and they're not as complicated as something with arms and fingers and multiple gears and sensors and all that stuff. It's a challenge, big challenge.
Yeah, exactly. Yes, that's you said it very well. So I can send out the link. So a couple of investment companies. So I only including this just because it's sort of interesting, but to me, this is not as important as some of the other aspects of what a humanoid robot is. But when you try to do a cost breakdown, and you try to come up in your mind how much a humanoid robot would cost, it to me just I can't even fathom how you could get a $20,000 humanoid robot and sell it and make any money at it. But I'm not talking about. I know Unitree. I think their base simple humanoid robot that Camp had that video of is like 16,000. But that's the base, the simple one without
It'll be
hands.
21,000 if you want it delivered.
Right.
Let me know.
Yeah. I wish I had 20,000.
We'll bring it to you.
Write a check for 21,000. I'll see we'll get you one.
Okay.
Actually, you can put as much as you want into these things. That's the beginning model. It's only remote control.
Right.
The state of the art with the Jetson Nano is like $65,000.
That's an expensive Jetson Nano.
I mean, it's really easy to make a small fortune in robotics. Just start with a large one.
That's always been that way. Always.
Right.
Yeah.
But then again, you look at it, like I say, when I was at that Los Altos Hills Community Center, I had a moment, sitting there with the humanoid and the quadruped, and having gone through the Gen AI conference and so forth, walking them around and that sort of stuff, and thinking about computers in 1982 and where exactly this is going to be in 20 and 40 years. Hold on to your hat.
Oh yeah, exactly. It's just so unbelievable all the cool things that are happening right now.
Yeah. And so, I mean, okay, $20,000 is a lot of money, but you're actually getting a damn functional humanoid robot, and when I went to the Gen AI conference, I'm going to hit somebody. It made me so damn mad because everybody, God, if I had a nickel for every time somebody asked me what my use case was. I'm at a Gen AI conference, and there's all this AI stuff, these avatars and personalities and authenticity checks and this and that, very academic, very virtual. Okay. And we've got this humanoid quadruped show going on over here in the corner. And we're developing software. We're developing software for the quadruped for security, monitors the surroundings and sees anything out of space, you know, but we also are distributors for Unitree. So we're selling them. And we also do promotional things. That's where I'm going to Atlanta, because this company that's got skin in the game, so to speak, is paying us to have a robot there, you know, just for the publicity, for the showiness of it. But the point of it is that, you know, for 20 grand, you can get in on the ground floor of this thing. And in 20 and 40 years, that'll be the best investment you ever made, right?
Oh yeah, yeah.
You can't even get an Optimus. You can't even get the Boston Dynamics humanoid, okay? But you can own the. Here I'm making my pitch, right? You can own the Unitree T1. So let me know.
Which one's Apple? Which one's the Apple guys? Yeah, that's what I want to know.
Apple has announced that they're going to. I mean, this is kind of what Michael's talking about here. It looks like everybody and their brother wants to be in the humanoid business now.
Well, I want to know who's the next Apple guy when it comes to robots. That's the one you want to invest in.
Unitree, definitely, Stephen. Unitree.
Yeah.
Bet it all on Unitree. Okay?
Thanks, Camp. I got insider tips. That's great.
You got it. You got it.
Yeah,
that's why they pay me. That's why they pay me the big bucks.
Well,
yeah.
I think, you know, we need approaches that can get the price way down. Right.
Yeah. That it's going to be interesting. The big thing I think will help out humanoid robots is mass production. It's like the old Henry Ford thing. The more you make, well, Walmart's the same way, but the more you make, the cheaper it will become. So, maybe in 20, 30 years, we'll get them down. We'll have a robot butler could do everything you want it to do and be under 20,000.
I think there are other approaches in the near term that could get it down much faster.
3D printing.
For prototyping and 3D printing is definitely the way to go. But yeah, approaches to both the joint design, the robot design, and sensing, and and powering, the actual actuation. So I think there are approaches that can drastically cut the cost.
Well, one of the things that's interesting is SpaceX took one of their rocket engines and got rid of all the complexity by making it printable, all the parts. And they printed, and all the passages and tubing and all the stuff that they had hanging on the outside, it's inside now. You can't even get to it. You'd have to cut it open with a torch. Now that makes it hard to fix.
Jet engines, right? And jet engines were revolutionized by being 3D printed. So, that's definitely a thing.
It can be.
Yeah.
Well, and the other thing, we are having some good areas that have come a long way. Like we have all kinds of sensors because of automotive and drones and e-bikes and other stuff, right? So we have all of these, we have some pretty amazing sensors that are pretty cheap because they make millions of them for vehicles.
Yeah, little TOF rangefinders for $36 I've recently seen.
What was that? Oh, the rangefinder.
Yeah, well, little TOF cameras for short range, which are nice for like putting them in the hand so it can see things. One of the things I think about the humanoids that's also really important with like the numbers that people are giving out and the robots in general is the long-term performance of the systems, because, and this is a big thing with like, especially like tech companies, they're really good at producing those demos. So they produce demos and then like, okay, folks, now you need to produce a robot that lasts for 20 years and doesn't break. Like, that's just like, they don't think that way. It's really hard for them to do that transition. What I've noticed, for example, with the Unitree, and also just the performance and the weight, what I noticed like with the Unitree dogs is I was at SRC and they were messing with one of them. and they put a bunch of stuff on the dog, and they pushed it close to the payload capacity, but the Unitree quadruped was overheating because its BLDC motors kept overheating. And so when they did the study, they had fans pointed at the robot to cool it off.
Yeah.
The other thing I think about humanoids a lot is, like the humanoid form, I think, is very limiting. And I think, like, for example, agility, they got massive gain by like flipping the direction of the legs around. So now they don't need to they don't need AI control, and now they can do classical control, so they can pass safety review potentially. And so I think I think that's one of the things you'll see with the humanoids is just like that. But ultimately, if you want a humanoid form, if you think about what we really are, it's just like two arms. We really like the part that's really good for it to be human-like is just the hands. So you can envision two hands connected to a non-humanoid robot, potentially being a lot cheaper than a humanoid.
They did some of those things with the Boston Dynamic robots and a couple more where they had arms and legs like a human, but then they added wheels to the feet.
Yep.
Like, it'd be like wearing roller skates for a human to work, and you can move a lot faster rolling than you can walking. So some augmentations like that could definitely make the productivity of the device a lot better because it could move quick.
Yeah, so the other issue is if you look at your investment generated content there, I don't know what it's saying the costs are for the full underbody of the robot, but I know that at bulk it can be $10,000 to $20,000 for a base with full navigation in all ADA compliant environments. So that base could be a lot cheaper than the base the robot's a wheeled base. So that could save you a lot of money on humanoids if you don't care about having them walk, which for a lot of environments you don't. And also it's really worth considering whether or not we should just put some ramps into the building.
ADA should have you covered there.
Yeah, that might not impact some of the factory scenarios. So if you look at like the Boston Dynamics dogs, where they're being used most is in like open environments where there's like stairs, like an oil refinery. So it's just like all these stairs up to the top of this tower so they can climb them up and down with the quadruped. And so there it makes sense because it doesn't make sense just to put in an elevator. But should we spend $11 million on robots or $1,000 to put in a ramp? I think we know what the answer is there.
Robots.
End up doing too.
Yeah, spend the robot. Have investors finance the money on the robots at a loss in hopes that data collection will make up for that somehow.
Yeah.
Well, we got to build up the quantity.
Yep.
I think the market for humanoids, it's human companions. That's going to be very big in the future. And if we're talking about prices, 20, 30,000, I'm sure a lot of them they're going to sell.
Yeah, I'm just going to be curious to see how soon we get to like this Morgan Stanley report that I got this picture out of. This is a couple months old, but they were saying 50 to 60,000. I think that's low, but you can see if you go through all the elements of what creates and makes a humanoid robot, there's a lot there. Extremely complex package.
The dolls sorry.
Yeah, no, that's fine. We could do a question and answer and talk about stuff. That's no big deal. Like I can't tell you how many different types of humanoid robots out. This is a small selection. There's the Unitree one there on the left, Boston Dynamics, Tesla, Figure AI. Don't get me started on Figure AI, but they're very good at raising money, very good showmen. But there's your agility robot, and this is just a small selection. I think NVIDIA had they were on stage at an NVIDIA event. There was like another 5 or 6 on that stage that I don't have. And kind of wrap up. I think I only have a few more slides, but the big thing they're talking about is humanoid robots, like in factories. This is where I don't know how you could do 24/7 with just one humanoid robot. You're gonna need multiples. I mean, everybody keeps talking about it's going to reduce labor costs. I mean, sure, I'm sure in the future it will. Of course, humans could get sick and get injured, and humans get tired, and they don't. Sometimes after a long shift, a human won't be as precise and as delicate and as do their job as quite as efficient as a robot. But do you really need a human robot to do manufacturing? I think that's a valid question to ask everybody. And then you have humanoid robots in the home. This to me, I know a lot of companies like Figure AI and some others are talking about how this is what they want to do. This is going to be this is going to be very hard. And the reason being is that your robots have to be extremely safe. You don't want a humanoid robot accidentally kicking or crushing a small dog or maybe even unfortunately a little baby. There's all kinds of safety problems I think you're going to have with humanoid robots in the home. You're going to have to be able to prove that that a humanoid robot can interact and not crush things, break things, hurt things. But the possibilities are huge for humanoid robots in the home. Like I said, we get back to the one humanoid robot per person. This is where that's going to happen. But you also got to consider all the complications, all the issues, and so on. But this is where the promise of a humanoid robot, because a humanoid robot will be just like us. It could walk around in a home. It should be able to walk upstairs. It should be able to interact with all the equipment, appliances in a home. But we just have to weigh balance and the good and the bad with the human robots in the home. This is another very interesting little diagram for that Morgan Stanley. There is so many companies in the world right now that have some involvement in humanoid robots. It's just unbelievable, all the different companies. I think Unitree's in here somewhere. I can't remember exactly where, but NVIDIA, again, I'm not really giving out investment advice, but NVIDIA is talking about how they have their, they create data to train robots on, and they had a big stage presentation where they had like 20 humanoid robots talking about all their latest computer tech and computer, training, compute and compute on the robots and so on. Inference, I think, is compute. If you're interested in doing a lot of investing, then it's just unbelievable all the different companies out there that have some involvement in software, hardware, sensors, actuators. But also, again, to me, this is where the complexity of humanoid robots is such that there's huge promise, but I'm sure there's going to be mountains and valleys and all kinds of interesting little detours and potholes and stuff that's going to happen in the next 5, 10, 15 years. This is another really cool graph. There's a lot of companies. This is, I think, sort of out of date, but there's tons and there's hundreds of companies getting into the humanoid robot area right now. China is big, Taiwan, Korea, Japan, everywhere. It seems like everybody. I think we talked about Apple and I think Microsoft and NVIDIA. All the big companies are getting into the humanoid robot area. I could send this link out. This is really, it's like 70, 80 pages of the humanoid robots and what's going on. I'm not giving out investment advice, but it's interesting to read all the interesting things that Morgan Stanley came up with. So.
All right. Thank you very much, Michael.
Yep. I think that's pretty much question time. Oh, That's not what I wanted to do. Sorry.
That was awesome.
Yeah, that was good.
Yeah. Then if you want to talk about, yeah, I got my STEM education. This is where I work. And then there's going to be lots of challenges and benefits to humanoid robots.
Oh,
And
you have
then
those
I think
robots
that's
where you
it.
work? Wow.
Thank
Is that
you,
one of your
Michael.
students? Is that a student there?
Oh, no. That's another AI, little AI generated little picture.
Questions?
And the thing is, I probably bored everybody, but I think I just scratched the surface of all the detail and all the different things going on with humanoid
group,
robots.
Michael. Not this group.
Yeah. We could,
So, have you heard of Groot? NVIDIA's Groot?
yes. I don't know a lot about it. It's like everything. It's like I'm constantly bombarded with, at least in my social media feeds, with the latest, greatest humanoid robot software, AI, constantly.
Probably should ask Dee Dee this, but what about InMove? Where's InMove these days?
Still building, I mean, 3D printing and stuff like that. I mean, it's been around for quite a while. They've updated it. The latest version has a silicon face like a Sophia, but it's not quite there.
It wasn't
Right,
too bad. I
there's
saw him at the
there-
Maker Faire. Yeah.
Oh yeah, I have a couple. I mean, you have the hardware, but it's the software, right? That's the big critical piece. And that accuracy, we're just using kind of hobby servos, so there's a accuracy concern I would have.
It seems like, or I should say, I know. Yeah, I mean, applying the LLMs to it and voice synthesis and voice recognition and stuff like that should be fun.
Yeah, I think there's that whole social robots. So the enemies could do great for the social robots, but the manipulation, that's the big challenge.
Any more questions for Michael? Once again, I want to thank you for jumping in and giving us this great presentation, Michael. It's so good to see you.
Yeah. Nice to see everybody. Yeah.
All right, very fun. Big round of applause. All right, so this is the random acts. Actually, I'll do this official. Like I make a motion this meeting be adjourned. Do I have a second? I think that was a second. All in favor say aye.
Aye.
Opposed say nay. Ayes have it, meeting adjourned. Now we're into random access. We're going to hang out in the parking lot until the security guards kick us out. Oh, next month is the challenge meeting. So I'm going to be bugging. Hey, Steve, I'm going to be bugging everybody online. Don't take it personal. Okay, I'm talking to myself when I do that. So next month is the 23rd HBRC challenge phase 1. And so we're going to kick it off with a bang. Everybody should be build something. Get your robot off the shelf, dust it off, charge up its battery, fix it, make it better, finish it. It's the challenge meeting, the HBRC challenge, phase 1.
This is the tabletop challenge thing?
Yeah, well, it's the HBRC challenge. The origin was the TableBot challenge, but that's while I got your attention.
Yeah, there's any number of categories.
Okay.
Pick one or just bring on something, or it's extended show and tell.
Challenges.
Yeah.
Challenges. Challenges. I'll put the link in the chat here. Boom.
I almost never fit a category, whatever I do.
Well, you do fit a category, Stephen. Let me show you here. Let me show you. It's the TableBot challenge. It's the FloorBot challenge. It's the AI challenge. It's the amazing LineBot challenge. It's the ArmBot challenge. RoboMagellan Trials,
Okay.
and Stephen, here's your event, okay? Here's your event.
Yeah, random
Run what you brung, okay?
random chaos. Yeah, that's more my.
Show your special one-of-a-kind robot that was not designed for a specific challenge. Phase 1, bring your robot, finished or not. If a finished demo, then spell out your phase 2 and 3 goals. Phase 2, bring your robot, finished or not. If it is a finished, define again your phase 3 goal. And phase 3, so you got March, June, and September. You actually have till September to finish your robot, okay? So you bring it in phase 1, tell us what your 2 and 3 goals are, and then by September, you should have a completely intelligent humanoid robot.
It'd be awesome.
Somebody's altering the terms of the deal here.
That's the reality distortion field going on there.
Question, Camp, question. One of the things with the table bot is, you know, the table. And we had some specific ones over on Castor Street. And are we gonna be doing it here in March?
You never know where you're going to be doing the table bot challenge.
Called
You
the
play
bowling
the
table
table,
parking
you play
lot.
the table as it is. Okay. On the other hand, we want to show your robot in its best light. So you're more than welcome to bring your own table, bring your own shoebox, and bring your own block. Okay.
Yeah. You have to use this table and watch out for the, you know.
I was going to say that table